now we get to bring out Holden. What's going on? Oh my gosh, I'm so excited to finally get to be on a virtual call with you. It has been a long time coming. I've been following your work since I think you were at Apple. And I remember my friend Willem saying like, oh, we should have Holden come and talk at one of the conferences we were having. And now we finally made it happen.
I'm happy to be here.
Excellent. Well, you've got some great stuff coming for us. I know that you have already shared your screen, so I'm just going to hand it over to you and I'll talk to you in about 25 minutes.
All right, rocking. So I'm going to try and get us back on schedule in part because I also have to go do work after this. Much less fun, I know. But so I'm going to talk about productionizing health insurance appeal generation. An alternative title for this was getting AI to production on-prem without a shoestring. But yeah, so I'm Holden. My pronouns are she or her. I'm on the Spark PMC. I work at Netflix right now. I don't represent them, especially in this talk, right? I'm talking very much about things that I do that are entertaining and fun. They bring me great joy. But they're not what my employer pays me to do. My employer pays me to work on Spark. So, related, big data stuff, but a little bit different. You can follow me on a whole bunch of different places. Twitter, Blue Sky, Mastodon. I do open source live streams, and a lot of the things I'm going to be talking about today, I also live stream. And if you're interested, you can go back and watch a lot of struggling with this. And I think that's interesting, or at least good, to see that you're not alone if you're struggling. And if you're not struggling, that's great. That's fantastic. Congratulations to you. So in addition to who I am professionally, I'm trans, queer, Canadian, although in America on a green card, finally. Took almost a decade. I'm part of the broader leather community. This is something that I say for a lot of my talks. I think it's important for those of us who are building ML models and tools to try and have more diverse communities in the room building these. Here it's a little bit more related because I've seen healthcare outside of this country, and also being trans means I have different interactions with American healthcare than some other folks. So there's going to be some references that people might not love. Feel free to come back for the next talk, and take a bio break if this is not your jam. And this is going to be an abridged version because we're running a little bit behind schedule. We can think of this talk as going from the laptop to the desktop to the server rack. All kinds of fun. So what is the problem that we're trying to solve with our computers? Health insurance in America frequently denies medical care. Anthem Blue Cross, who is the insurer that I have currently, denied around 20% of claims, more than that in 2019. And so they've consistently been denying a lot of claims. And Anthem is not alone. This is just the insurer that I happen to have. Allegedly, some of them are using AI to deny claims. Of course, they deny that, but I somewhat trust the reporting a little bit more than I trust their denials. The other part of our problem is that my budget is super low, right? This isn't a problem that I'm solving for Netflix. This is a problem that I'm solving because I have it. And so the resources that I have versus the resources a large employer has are a little bit different. Personal motivation, I got hit by a car in 2019. Lots of medical bills as a result of that. Also being trans, bunch of surgeries. Personally for me, not every trans person decides to have surgery, but I've chosen some different things that have really helped with my life. I love them. But also a lot of medical bills and a lot of fighting with insurance. But my dog is amazing and he helps me get through all of this. His name is Timbit. So I also want to be clear and set realistic expectations, right? This is the flex tape slap-on approach to trying to solve what is fundamentally a societal problem. Health care should be accessible to everyone. And there's only so much we can do with computers, right? We can try and make things better, but structurally, America needs to change. So how are we going to use computers to try and make the world suck a little bit less? So we're going to make an ML model that'll take health insurance denials and produce appeals for people. And then, because that's only part of the thing, most people don't actually have like a RTX 4090, let alone necessarily want to install Python or download a model off of Hugging Face. We're going to put together, a front end to access the model. And to be clear, like, this is my approach. There are many other approaches that one could use to try and make healthcare in America more accessible to people. So we're going to need training data, we're going to need evaluation data, and we're going to need a bunch of computers. And then we're going to need some software to put everything together. So training data is like, that's the hard part, right? The people that have them for the most part are insurance companies and doctors' offices. Insurance companies aren't likely to help us because, well, our goal is to make their lives harder. And doctors' offices are unlikely to help us because while our goal is indeed to make their lives easier, there's a lot of laws that they have to be sort of very careful about when it comes to sharing information. And so they'd have to go ahead and go in and manually redact all of these things. And, like, hey, I can make your life easier, just spend the next like few months redacting patient records, just that doesn't sell very well, right? We can look at the internet. Some people post their denials and appeals online. It's fantastic, love it. Great data source, not big enough to fine tune a model. But there are other sort of substitute data sources that we can use for training our model. The independent medical review boards. Now, California has this data and it's open and you can download it. Thank God. Other states also probably have this data, but it's not as open or it has restrictions around it. Washington State, for example, has it, but it's not approved for commercial use. Is this commercial use? I don't know. I also don't want to be the one that finds out. So we're just using the California data for now. One day in the future, maybe, we'll file a Washington State Freedom of Information style request and get the data from other states, Texas, et cetera. Every state has independent medical review boards. The results that are published don't contain the patient name or really too much information. So in theory, these things are difficult to figure out who it would be. It probably is. And the great thing about this is that there's a lot of these, right? Like the state of California is big enough that there are so many of these records, and we can take these records and we can generate synthetic data that we can use for fine tuning. So we're going to ask our LLMs to take our inputs, these are what our inputs look like, and output what the denials might have looked like, and similarly, appeals. There's some downsides to this. The generated data costs money to generate. Not a huge amount compared to like having humans do it, but the generated data might not be very good. So then we have to do some filtering on top of it. And we also have to be careful with what licenses we use, what license models we use. So let's say we go ahead, we do that. We've got a bunch of data. And then we're going to go ahead and we're going to pick a model to fine tune, ideally one that otherwise performs well and will fit on the kind of hardware that we happen to have available to us. Sorry, that's my dog. He's very upset. Normally, this is the sign that the mail is about to arrive. Could be something else. Thankfully, this has gotten so much easier. Fine tuning things is fantastic. I use Oxalotl. I don't actually know how to pronounce that properly. The first attempt I used Dolly and a whole bunch of shell scripts. Oxalotl abstracts away almost all of these terrible shell scripts into terrible Python scripts. And then Lambda Labs, because while I have an RTX 4090, an RTX 4090 isn't enough to fine tune the model. It's enough to run inference on it, but that's good. And then we've got a whole bunch of shell scripts still because copying the data around, doing all of the setup on all of these computers is kind of painful, but it's much better than it used to be. And then we write some relatively simple config files. We write a model fine-tuning config, specify what our base model is, where our data is coming from, sequence lengths, sliding window, then some special tokens. And fine-tuning the model, all told, it costs about $112, right? That is not too much money. It's not like, you just do it because you feel like it, but it's certainly within my budget. And then it's time to serve our model. So we've fine-tuned it, and we want to do our serving. VLLM, really cool. We still need some GPUs though. I have some ARM GPUs, ARM plus GPU things from NVIDIA. Really interesting devices. They don't party very well with most of the tools. The other discovery that I made is that an RTX 3090 does not fit well into any of the 2U servers that I have. They also still cost money and use power. So we ended up using a desktop computer and shoving it in the bottom of this rack that's pictured here. I don't have a picture of that particular abomination, but it's okay. Used more power than I was expecting, so I had to shuffle things around because I've only got 15 amps to play with. But not too expensive. And then doing the actual serving itself is relatively simple, right? We can specify a Kubernetes deployment, and this will just take the VLLM container and run it on Kube. Here we see that I limit it to the AMD 64 hosts because the ARM hosts don't play nice with it right now. The runtime class has to be NVIDIA. That way we can actually access the GPUs from inside of our container. And then we also add some additional arguments. And this is like, hey, this is the model that we're using. Listen everywhere. I don't know what enforce eager does, but if we turn it on, it works. And if we don't, it doesn't. Bit of a joke. One of the things that you'll note here is that we're pulling from latest. This is not a good idea. And in practice, this actually does break every so often. Originally, I was pulling from the Mistral container with latest, but periodically the Mistral folks update their containers and they generate the prompts to the model differently. And they do this ahead of releasing any of the source code changes. So you don't really know that's going to break until it just breaks. So you should actually pin to a specific version. Oh yeah, the other thing here is we need a fair amount of ephemeral storage because that's where we download the model and put the model. RTX 3090, $748. It's more than it costs to train the model, but it's still, that's pushing my budget limits, but it's a lot cheaper than renting a GPU with enough RAM to run model inference for like a year, right? This is much more affordable. It's a front end. We put it together in Django because I work in Python and Scala, and it's a lot easier in my experience to make a front end really quickly in Python. Also, LLMs do a pretty good job of generating Python compared to generating Scala code. These can run on pretty much any of the computers that we've got in our rack, so it's probably actually running on some of the ARM machines. It's pretty great. Those ARM machines are super efficient power-wise, so I love that. We also need internet access. This is a bit overkill. So here we've got an autonomous system for Pixconfly Labs, and it has 3 upstream internet providers. It's fun. If you took a Cisco networking class when you were in high school, this may be your dream from being a small-ish child. If you didn't, you may be like, Holden, this is silly. And you are right in either case. But if you want internet transit in Hurricane Electric Fremont 2, give me a call. And now we're going to go ahead and do a demo. And I'm going to really hope that it doesn't crash. The other thing that I want to be really clear about is please don't use this right now in real life. It is not super ready for production usage. Okay, and we're going to see if it loads. Otherwise, we're going to debug it in real time. Let's see if it'll let me share a screen. Okay, so here we see, this is sad. I'm not getting any pods back from Totally Legit Co right now. So that would be why it's not coming up. And this is how we know it's a real demo, not a fake demo. Let's see. Why is it broken? I love computers. Okay. So our router's up. That's a good first step. Let's see here. Can we SSH to? Oh, okay. That's why the computer running it crashed, most likely. Well, see if I can try another machine really quickly. Okay, that machine's up. Okay, so yeah, okay, Jumba is down. So that's not going to work. We're going to send an email to the fine folks at Hurricane Electric to reboot Jumba, but that's not going to happen. In time to run the demo. So that's okay. Instead, let's go back and look at some of the places where this code lives. So most of the logic lives inside of totally legit code. So the LLM stuff is all inside of this health insurance LLM repo. And we can see our deployment code lives inside of here, as does our fine-tuning code and all those things. So if you want to play with this and you have a Kubernetes cluster that is currently up, you can go ahead and deploy it. In the meantime, my cluster is down because it looks like the head node is also the node where the model inference is running. So it's just not going to work. But you can go ahead and run it too. Downsides of on-prem is it takes real time to reboot computers instead of fake time. The front end, which we can actually somewhat look at today, because I can run that locally. Oop. Yeah. There we go. Oh. Is this the 8,000? Why is it not listening? Oh, sorry. Demo sadness. Run local, yeah. Let's, Oh, Docker container, ls Docker container stop. Got the model running locally too. So we'll stop that so we can bring up the UI. And then, cool. Should work. Come on. Loading. Well, yeah, let's call it on the demo. I don't think that's going to work, and we can have 2 minutes for questions. I'm sorry the demo didn't work, folks. Really bad luck with that computer crashing, but we know it's not staged because it didn't work. So
I was loving it. I am so excited that you were doing this. This is very cool, and that you broke down every piece of this puzzle. It's so much more than I usually think most people will talk about, and so that's awesome. Now there are some questions coming through. I mean, we'll start with some basic ones, which are, what is Jumba?
Okay, so I shouldn't say all of my servers. Most of my servers are named after characters from Lilo and Stitch.
Oh.
So here, Jumba, Lilo, and Stitch. If if you want to bring the screen back up, you can see Jumba.
That is
This
Jumbo. I
Jumba
thought it
for
was a
Rowan.
service and it was that is classic. Okay, yes. Perfect. There is the first question. Now, I'm sure more people have a few more questions. One is, yeah, this is Kubernetes serving. We definitely saw that. Um, do you, how do you feel about CPUs versus GPUs? Do you ever try and run it smaller?
Yeah, so that's a super solid question. I've played with CPU inference, and it's never given me particularly great results here. Um, Part of it is, I think that realistically, like this is already like we're fine tuning a model with a synthetic data set, and it works okay, but it doesn't work amazingly, right? And so when we throw away like these extra bits of precision, it's not super fun. The other reason why I kind of like didn't go down super far down the CPU serving path is that the bits and bytes library, which a lot of things are used for quantizing, doesn't work super well on the ARM nodes that I have anyways. And by doesn't work super well, I mean doesn't compile. Um, and so, yeah. So it's like, yeah, I could run CPU inference on an x86 node, and it would kind of work kind of slow, but my x86 nodes are already pretty power hungry, and so
Mm-hmm. For all of us that really enjoyed this, you do this often, right? On Twitch?
yeah. So I do this very often on Twitch and YouTube, and so later on this week, once that node is rebooted, I'll redo the demo on my YouTube and on my Twitch. And if you want to see that, I'll post a link to it, and we can do that there. I'm really sorry about the demo again, folks.
We are all very forgiving
Thank you.
because
I
you
appreciate
haven't
it.
heard my singing. People are people are very forgiving in this because you know what? They're about to hear some horribly out of tune singing that's going to happen. Your demo is the least of their worries. Anyway, there's some questions about the GPUs and if you use any special cooling when you're working with them.
Totally. So for inference, I have I have two GPUs, and all I do is it's just sticky to one GPU for inference. The reason why I have two is I had the theory that like it might make sense to have a second model for inferring additional information. So instead of just generating the PL extracting information from the denial, but it turns out that honestly, one model was pretty good at doing both. And so that's cool. That does let me start up a new model without having to take the old model offline first, which is great. But as we see, physical nodes fail. So only so great. For the fine tuning part, that part I leave up to Oxalotl for the most part, and it does a really good job of splitting up the work on multiple GPUs automatically, and I haven't felt the need to do anything funky with it. Like NVIDIA SMI shows like everyone's happy and using a bunch of power and chugging away. So that's been great. I'm really happy that I don't have to think about that problem.
Nice. Have you found any tricks or tools that you like just to make sure that you are getting that full saturation of these GPUs or speeding up the inference on the other side of things?
Yeah. So for like making sure that I'm getting the full strength of it, on the fine tuning, that has not been a problem, right? Because the Oxalotl does a very good job of picking batch sizes that just like clobber the GPU, and you can just watch the temperature go up and the power consumption go up, and you're like, okay, cool, good luck, don't catch on fire. For inference, so while there are a lot of health insurance denials, right now this is like a thing that I am building that I am using, And so my batch size is 1. And so like that is obviously suboptimal. But I use VLLM in part because of the theory that once we achieve a second user, we'll be able to go up to a batch size of 2, and that'll do a better job of getting the GPU utilization better. So that's why I use VLLM, so that we get nice batching. That hasn't played out in practice yet, just because it's like very early stage.
Nice. Last question for you.
Totally.
Coming through in the chat, asking about for inference. You mentioned CPU is not great and it hasn't really worked for you, but you were talking about the AMDs, right? What about, have you experienced with, or have you played around with Intel optimized libraries like Intel-X, etc.?
Yeah. Sorry, when I say AMD 64, I just mean x86_64. That's my bad.
Oh, okay.
It's just because that's the what the nodes get labeled in Kubernetes for whatever reason. But no, I haven't played with the Intel-specific accelerator libraries. That is in my list of things to do and explore, because I think it looks really cool. And that's actually something that I want to explore for my day job too, because we've got some things that I think we could accelerate with some of the cool Intel stuff there. So if that's something that like someone else thinks is cool, like reach out. I'd love to chat. You can find me on LinkedIn, Twitter, and all those places.
There we go. Excellent. Well, Holden, this has been an absolute pleasure. I'm so thankful that you decided to come on here and code with us, show us what you're working on, and it has been a long time coming. Thanks so much.
Thank you so much for having me. I really appreciate it. And next time we'll have a working demo.
There we go. We'll find you on Twitch. Don't worry, and we'll be watching. So
okay, awesome. Thank you so much. Thank you.
See you, Holden.